Okay, once again, class. So, this is just a continuation of the previous presentation. So, for this one, we are looking into the estimation of a population proportion or a population percentage or percent. So, depends on the problems given, class. Okay, so when we approximate or when we estimate a population proportion, so the data that we are going to gather, class, either in terms of percentage or perhaps in terms of proportion, and there is a different formula that we can use, especially for the standard error of the proportions, which is different from the standard error of the mean. However, the process, class, is similar to that of estimating a population mean. So for the population proportion, class, so to estimate the population proportion P, the small p, okay, so we need the point estimator, the proportion, we just call it a p hat, is equals now to your x all over n, which is unbiased, with the standard error of your square root now of the product of your point estimator, okay, and it's we call this class the q hat. So this is actually, class, the complement of your p hat divided by your n, where your q hat is the complement of your p, meaning if your p, class, is in terms of percent is 25%, then your q is the 75%. If your proportion p is zero point 0.7, then your q hat is zero point 0.3. So we have to subtract it from 1. So that when we add, it goes back again to 1 or 100%. So the margin of error, class, for the population proportion is given by, if you notice, class, they are exactly the same using the population mean, the critical value times the standard error of the proportion. However, the only difference, class, is the formula for the standard error, which is can be estimated as the square root of the p hat times q hat divided by your n. Okay, so the same critical values we are going to use. The only difference, class, is your sample, we call this now the standard error of the proportion. So still, we have the 90% confidence, the 95% confidence, the 99% confidence with their corresponding critical values multiplied to the standard error, which is this formula above. And of course, instead of the mean as the point estimate, we are now using the proportion. Okay, so that's the difference, class. Okay, so it is based on the problem kasi, class. So sometimes you are given the proportion, sometimes you are given the percentage. So you really have to be careful, class, what is the given. Okay, so if you are given in the in proportion, then these are examples of proportion. So typical is the 0.025, okay, and this is actually usually used by the dividing the number of success by the total number of observations. So this is your uh, common formula for a proportion. Say for example, 50 out of 125 when converted into a proportion is equivalent to zero point 0.4. The percentage, on the other hand, is simply multiplying the proportion by 100%. So that 0.025 times 100% is 2.5. And in the formula, we always have multiplied by 100%. So example is 50 divided by 125 is zero point 0.4 times 100% is 40%. But during the process, class, of solving, we use the proportion. But when we answer, depends now on the question. So if we are asked for a proportion, then our answer should be in proportion. If we are asked in percentage, then our answer should be in percentage. So we must be consistent in our solution, not in the solution, class, but in our interpretations. Okay. So we have here another, okay, first example rather. So 500 randomly selected adult residents in a city are surveyed to determine whether they have smartphones. So we are looking at the adult residents. So when we say adult residents, class, so if you are now basing it on the legal age, it could be 18 and above. And there are 500 who were selected randomly in a particular city, and they were asked whether or not they have smartphones in particular. So regardless of the brand, if they are considered as smartphones, then that would be counted. So of the 500 people sampled, 84% responded yes, they own a smartphone. So this 84% class is given in percent. Okay, so be mindful of this one. Using a 95% confidence level, you are going to compute a confidence interval estimate for the true percentage of all adults residents in this city who have smartphones. In other words, class, we are only using a sample of 500 in that particular city. We want to estimate if what about if all the adult residents in that city, okay, if you're going to consider that, then how many percent, because I think that's the one percentage of all the adult in that particular city has a smartphones. So what are the data that are given here in the problem? So again, we have n. This is the sample size of 500. Your p hat here is the sample proportion or percentage of 84%. So as I said, you have to convert this into a proportion. This is 0.84 because we are using the proportion class in the process of computation, not the percentage. Then its complement class, if 84% have smartphones, then your Q hat is how many percent doesn't have smartphones. So if 84% have smartphones, then 0.16 or 16% doesn't have smartphones. So yung ibig sabihin nito class, it's the complement. And when you add again 84 plus 0.84 plus 0.16, it goes back to 1. Or 84% plus 16%, it is 100% total. So that's the concept class of your Q hat. It's the complement of your P hat. So this is your sample proportion, and this is actually your point estimate. Of course, the 95% confidence is given, so the correct critical value class is 1.96. So that our margin of error at 95% confidence could be 1.96 times the standard error, or that would be 1.96 times the square root of your P times Q all over N. Okay, so applying the formula, now the data. So 0.84, again, use the proportion, not the percentage. Then your Q hat is the 0.16. You divide it by 500 because there are 500 cases. Whatever is the result class, take the square root. The result is your standard error, which is 0.016. So I just rounded this to 3 decimal places. Then multiply this now to 1.96. Then the result is the margin of error. So this is 0.031. In percentage class, this is about 3.1%. Ayan. So ito yung ima-minus natin at iso-subtract or minus or i-add into the point estimate of your p hat, which is 0.84. Okay, so again, before we convert this into percentage or into proportion, so we always use the proportion as our base class in solving. So therefore, to find now the confidence interval, so your point estimate is your p hat plus and minus 1.96 times the standard error, or this is your margin of error class. So that's 0.031. Then 0.84 plus and minus 0.031. So you will have your lower and upper limits. So when you subtract 0.031 from 0.84, that would be 0.809, or in percent, 80.9%. The upper limit will be 0.84 plus 0.031. That is 0.871, or 87.1%. So I put here the percent class because the problem calls for percentage. Okay. So therefore, we can have our interpretation now. So we already have the confidence intervals. So at 95% confidence. So with 95% confidence, the true percentage, because this is the one that is being asked class, it's the percentage, not the proportion. So the true percentage of all adult residents of the city who have smartphones is between 80.9% and 87.1% inclusive. Yan. So, be careful, class, of your answer in terms of proportion. So if you are asked for percentage, then the answer should be in percentage. So caution, if the problem asks for a proportion, not percentage, then use the proportion 0.809 and 0.871. So be mindful, class, of what is being asked. Is it in percentage or is it in proportion? Okay. Another example. So suppose 250 randomly selected students in a university are surveyed to determine if they own a tablet. So regardless of the brand, as long as it's considered a tablet, then there is a survey, 250. So of the 250 surveyed, 98 reported owning a tablet. Using a 90% confidence level, compute a confidence interval estimate for the true proportion of all students in that university who own tablets. Okay, so we are asked for a proportion, class. So be careful of this one. It might be that your answer will be in percentage. Definitely, it will be marked wrong. Okay, so what are the data given? So this is the sample size of 250. Of the 250 class, how many said that they own a tablet? That is your 98 here. So that's represented by your X. So to find the proportion, class, you need to divide 98 by 250. So that's the one here. Then the result is 0.392. This is an exact value, nagkataon lang, class. In case that when you divide or you take the proportion and if the result is non-terminating, so you can round your answers up to 3 decimal places. So this one here is an exact, okay, division. So, or an exact decimal, class. So this is now the proportion of those, okay, students in the university who owned a tablet. So in percent, this is about 39.2%. So how many of the 250 students being surveyed doesn't have any tablet? And that would be your Q hat. So that would be your 1 minus 0.392, or that is 0.608, or that is 60.8%. Since 90% of confidence is given, then the correct critical value, class, is the 1.645. Okay, so that's the one that we're going to use. So that at 90% margin of error, our formula would be 1.645 times the standard error for the proportion, which is this one formula, class. So we use this formula to solve for the margin of error at 90%. Okay, so ito yung nangyari, class. Ayan. So, substituting the values of your standard error here. So, P hat is 0.392. Your Q hat is 0.608 divided by the number of sample size of 250. Take the square root. The result, class, is your standard error of 0.031. When you multiply the standard error by the critical value of 1.645, round your answers to 3 decimal places, the result, class, is the margin of error. So this is the one that we're going to add and subtract from the point estimate, which is now the 0.392. Okay, so that will be now the next step in creating our confidence intervals. So the confidence interval now is your point estimate in terms of proportion, plus and minus your margin of error. So substituting that, so 0.392 plus and minus the margin of error of 0.051. So the lower limit now is 0.392 minus 0.051 is 0.341. While the upper limit is 3.392 plus 0.051 is 0.443. And this will be the range, class, of the uh, interval. So therefore, going back to the questions, because we are asked at 90% confidence, we are asked for the proportion, class, not the percentage. So be careful of this. So with 90% confidence, the true proportion of all students who own tablets in the university is between 0.341 to 0.443 inclusive. Okay, so since we are asked for the proportion, then the answer should be in proportion. Okay, so if the problem asks for a percentage, then convert this into percentage class. So this is how we usually answer or make an interpretations based on proportion class. So either you present it in proportion or you present it in percentage, and that depends on the problem given. Okay. Personally, class, my choice is always the percentage. Yeah, because it's easy for us to comprehend when it comes to percentage. So another example here, a student polls his school to see if students in that school that he, okay, enrolled are for or against the new legislation regarding school uniforms. There are some universities actually, class, that they implore the use of the wearing of the uniforms regardless of their courses. Ito yung mga exclusive schools, class. So, it so happens here in Baguio, hindi siya uso. But for some courses, meron. Okay? But if you are in the other universities, class, especially run by the priests or the nuns, or these are now what we call the sectarian schools. So, regardless of the chosen degrees, there is always a uniform. So, she surveys, his yun, dapat he. Okay. His. Dapat yan ay he. Okay. He surveys 600 students and finds that 480 out of the 600 are against the new legislation. So, compute in 99% confidence interval for the true percentage of all students who are against the new legislation. So, it's only 600 being surveyed, and based from the 600 class, 480 are against the new legislation. So, if you're going now to find, okay, or to estimate what will be the true percentage if all students, okay, give his or her opinions about the legislations of e-uniform. Okay, so what are the data that we need? So there is a sample size of 600. Your 480 is the one who said that they are against the new legislation. So converting this into a proportion, so x all over n, that's 480 divided by 600 is 0.8. So this is a terminating decimal. Then what will be the proportion, okay, that is pro the new legislation? So 0.8 here, class, is the proportions that they are against the new legislation. The Q here, the Q hat, is the those proportion of students out of the 600 who are pro. Okay, they are not the against, but they are pro or for new legislation. So that is the 0.2 or 20% remaining. Because we are given the 99% confidence, then the critical value is the 2.575. Okay. So creating now our margin of error formula, so we use the 2.575 times the standard error given by this formula here. So we use this to find for the margin of error. Okay, so the margin of error now would be, of course, the 2.575, again, you have the plus and minus times the standard error. Substitute, 0.8 is your p-value, your 0.2 is your q hat, okay? Then divide it by the 600. Take the square root, the result, class, is your standard error, which is 0.016. Multiply this to the critical value at 99% confidence. The result now is the margin of error of 0.041. And this margin of error, class, will be the one that we are going now to add and subtract into our point estimate as the sample proportion of 0.8. Okay, so we have our confidence interval, the point estimate proportion, plus and minus the margin of error. So the point estimate is 0.8. This is the sample proportion plus and minus the margin of error of 0.041. then we have our lower and upper limits. So 0.8 minus 0.041 is 0.759, or this is about 75.9%, while the upper limit is 0.8 plus 0.041, or this is 0.841, or 84.1%. So you notice, class, that I am now converting this into percentage because in the problem we are asked the percentage, not the proportion. So we will be using the percentage. Okay, so with 99% confidence, the true percentage, ayan, because we are asked for the percentage of all students who are against the new legislation is between 75.9% and 84.1% inclusive. So medyo mataas, class, yung na-survey nila na they are against the legislations of having a new uniform. So ayaw nila, class, majority, hindi bababa sa 75.9, hindi lalampas sa 84.1. So medyo marami ang against the law. So again, caution, if the problem asks for a proportion, use the 0.759 and 0.841. But since we are asked for the percentage, so we must give the answers in percentage. So you notice, class, that when we compare these computations to the population mean, they are similar or the same. The only difference is the formula for the margin of error, especially the standard error formula, class. But the rest, they are exactly the same. Okay. So once again, class, so I hope you all have already the idea on how we estimate a population parameter, either the population mean or the population proportion or percentage, using now the concept of confidence interval. Okay, so thank you for your time and see you again for another lesson. Bye-bye.